Welcome, students, to Formulating Absolute Value Equations. These are on the back of your Inequalities second page. So these are coming up on CBA number 1. You'll have, I think, 1 or 2 of these type of questions. This is October 4th, which is a Wednesday. So just FYI, that's coming up. To write a basic absolute value equation or inequality from a word problem, you just need to remember this. You're going to set up your absolute value with x minus whatever the goal is. And we'll refer to several so you can see what in the world I'm talking about. And then you'll have your absolute value symbol, whatever happens to be, or your equal sign or whatever. And then your difference, basically your give or take. So let's just jump into one so you can see how this would work. So example 1, a pair of earbuds you want to buy cost around $15. So that's the goal. You're trying to spend around $15 on a set of headphones. Give or take, oh, there it is, that's your difference, depending where you buy them. So write and solve an inequality to find the range of prices that this pair of earbuds could cost. So let's start. So I'm going to start with x minus whatever my goal is. So my goal price is $15. And we'll get to the symbol, just leave a space for the symbol. And then give or take $3. So basically I'm willing to spend anywhere from $12 to $18 on these earbuds. Now, I don't want my difference to be any more than 3. I want my difference to be less than 3 or equal to 3. So pretty much if you see the phrase give or take, it's usually going to be this symbol that you want. Or if you see no more than, this would be no less than. And less than. And then more than or greater than. Those are just some guidelines to go by. So now I got my equation. It was that easy. I just plug in 2 numbers and pick the right symbol. And then I just have to solve this. So let's do reverse Pemdas. Notice there is nothing to add or subtract outside the absolute value symbol, and nothing to multiply divide outside the absolute value symbol either. And there's certainly no exponents. So now we're inside the symbol, which means I need to split it. So you know what? Let me start again up here because I wrote that super big. I don't know why I did that. So x minus 15 is less than or equal to 3. X minus 15 is greater than or equal to negative 3. So don't forget to flip the symbol and make that negative. And then I'm back to the bottom of reverse Pemdas. So can I add or subtract anything to get the x by itself? Well, sure, I can add 15. So x could be less than or equal to 18. And x is greater than or equal to 12. Which means, and some people like to see a number line. That shouldn't be there. 15 was our goal. 12, 18. So I could be less than 18, but more than 12. So there is your solution. So let's do 2 together, and then I'm going to ask you some questions about number 3. So number 2, a factory builds a part that must measure 15 millimeters across. If the part differs by more than 5/100ths of a millimeter, it must be rejected. So my goal is 15 millimeters. And this is my difference. It can differ by 0.05 millimeters and still be okay. So then we want to write and solve an inequality to find the range of acceptable measurements for the part. So let's see. So I'm going to start with x minus my goal. So x minus my goal, and my goal is 15. And then leave the symbol for now. We'll work on that in a minute. And my difference, or my give or take, is 0.05. Okay, now what symbol goes there? Well, I want to find the acceptable measurements. So for the measurements to be acceptable, my difference can be no more than this. So here's no more than, just like that. So then let's go ahead and solve that. So I'm going to rewrite it over here because again I wrote super huge. Let's do reverse Pemdas. So can I add or subtract anything outside the absolute value? Nope. Can I multiply or divide anything outside the absolute value? Nope. Do I have any exponents? Nope. Yay! Now I'm inside the parentheses, so I can split my absolute value. Remember, the first one roughly stays the same, and then the second one would go all the way over here because I didn't leave enough room. X minus 15 is greater than or equal to negative 0.05. So I'll just remember, flip the sign, make that negative. So then I can add 15 to both sides of both equations. Please remember to add like place values here. Don't make that 0.20, please. So x is less than or equal to 15.05. X is greater than or equal to 14.95. So there's our solutions. And if you want, if it helps you to do the number line, you can. But there's your solution. So now I want to see if you can write your equation for number 3. So give it a shot and then come back and check it. So that's how your equation should look. X minus your goal, which is 25 feet in width, and then the tolerance is 0.5. And since we want an acceptable range of street measurements, that means our tolerance can't be any more than 0.5. So no more than is this symbol right here. Okay, now see if you can solve it and then come back and check again. So here's what solving example 3 should look like. So you get x is less than or equal to 25.5 and x is greater than or equal to 24.5. And if you wanted to draw and shade your number line, that's what it would look like.